So here we go. Should I really welcome the stats, for like Bryant? Okay. No, I don't recall that. Alright, here we go. Review and preview of hypothesis testing. Now, I'll also tell you the difference between this course, which is Math 108, and the difference between Math 160 at Parkland. You're doing the 108. We spend one chapter on hypothesis testing, and 160, which is regular statistics, they do 3 chapters on hypothesis testing, and they do dual tests. We do single tests, okay? So that's the difference between 2 courses. So if you show up at Parkland and say, oh, yeah, I've already taken stats. Well, you have, but be careful which one you're signing up for. Okay? So, review and preview. We're pretty good at that. Hypothesis is a statement about a population, not a sample. That's kind of a big deal. Hypothesis is a statement about a population. Statements, remember in mathematics, are either true or false. You do not have to be in between. It can be either way. That's why it's so important. When you find one thing wrong with the test, the whole thing is done. The whole thing is false. You don't get second chances. Remember on those boards, if it failed one of the 3 criteria, you couldn't do the z interval. You couldn't do the t interval. Okay, it was neither. So that's important. Statements are true or false. For false, you just have to find one. Just one exception. Just one exception, and you're done. If you can't find that exception, then it has to be true. Okay? Make sense? That's kind of a big deal. Hypothesis. In geometry, those of you who took geometry, your given was what you knew. Your proof statement was your hypothesis. That's what you're trying to prove. In statistics, we talk about population. Okay? So, in this, next thing is hypothesis test. It's a test of significance. You don't have to write this down because you can be writing this down a lot. You're testing a claim about a population. What were the 3 things we tested back there? What was p-hat? You know what p-hat stood for? We just had a test, and we went to see Macbeth, hope it all went away. Yep. It was the best point estimate of what? Population. That was X bar. Mean was X bar. Chi-squared we used for standard deviation and variance. What was the p-hat? What are the words with the, I'm going to say it, proportional percents? You remember? 78% of people are going to go for this person. That's a population proportion. So these are the 3 things we're going to be testing. Those claims. Are you testing a percent? If you are, you're still going to use board 7.2. Are you testing a mean? Which is 7.3 or 7.4. Are you testing a standard deviation or variance? It's board 7.5. Get the idea? Okay, so that's where we're going. We're going to test it. Alright, the main objective of this is to develop the ability to conduct a hypothesis test about a population mean, p-hat, x-bar, or standard deviation. Khan Academy also has a video on this. If you go to Khan Academy, you can watch it. And then talk about hypothesis testing. These are examples. Don't leave them in the book. We'll talk about them later. About genetics, the business, and the medicine models. This is a big one, the medicine model. If they can do a drug to a hypothesis test, they can start selling it to make a lot of money. Okay? So researchers are always claiming something. If you want to make something true, you always make a claim. Okay? Have you ever heard a commercial come on television for some pharmaceutical? At the end of the product, some song cuts right over here. And you hear at the end of the commercial? Those are the disclaimers. But they don't want you to really pay attention to that. So that's why hypothesis testings were set up. Alright. More about something like that. Okay, so, have to be aware of the data. Number, simple random samples, that's true. We're trying to get normal distributions, that's true. And what type of sampling method is used is also important. So here we go. Don't write these down, like I said, you'll be doing them a lot. Just understand common words for right now. Just get to know the language. Remember the stats, that's the big thing. The language. How to identify a null hypothesis and an alternative hypothesis. Okay, so that's what we're going to do first. We're going to talk about what is a null and what is an alternative hypothesis. Okay, we'll talk about those. You have to identify that in your test. So this will go into your answer about the claim, how to express both. We're not going to write them out, we're going to use symbols. Okay, so that's the first thing you always do to write this is what is the null, what's the alternative. Second thing, how to calculate the value of the test statistic. That is p hat, that is x bar, that is the variance and the standard deviation. The boards. That's how you calculate it. That makes sense. That's why to be sure this was so well understood by the class before we went on. How to identify the critical values. The critical values are z, alpha over 2, t, alpha over 2, p hat, and the chi-squared, left and right. Okay? Those are critical values. What are the critical values? What it does, remember you do the pictures? If something happens in here, it's very unlikely, isn't it? If that happens in a very small area of the curve. If something happens in between here, it's probably true. It's probably likely that it will happen. Does that make sense? Okay, so that's part of it. The p-value we have not talked about yet, but that's the number one way of doing a test statistic, the p-value. That takes all the z's, t's, and compares them at the same level. Okay, so that's a pretty powerful number. And this one, how to state the conclusion. Unfortunately, every conclusion in this room will look exactly the same for a while because you'll just have to rewrite what they write until you get the hang of it. Writing the conclusion is very important. And it's also has to have everything in it. The null, the claim, the test statistic, everything. But if you tell by your assignment, I'm not giving you 55 needs to be a night. I've pieced it out over 4 days. Normally it's just 1 day, isn't it? So I'm giving you time. And you're going to use your time in class to work on this. Okay? So here we go, part 1. Word event rule. That comes up not as much as you think. This is kind of like the trap door, the plan B. If you come up with something but you still think it's not right, and you say, you know what, I still think it's right. I'm going to throw out the findings. I'm going to go with the common sense and say this isn't true because it's got to be a real event. Okay, you can always do that. In calc and in trig, you can't do that. You go with the findings. All right, so that's kind of the important part. So here's the word event rule. Okay, just read this and give it a thought. That way I can't tell if you actually did it or not, but don't try to write this down. These are going to be posted online anyway. Movie patrons have IQ scores with standard deviation that's less than the standard deviation of 15 for the general population. First of all, if you read that, does it even make sense? You're actually going to find out about statistics. You know what movie patron is? Okay. Standard deviation? So that means they have a standard deviation less than the standard deviation of 15. So that means the IQ scores are tightly put together. Whereas in the general population, a standard deviation means you have a wider range of scores. Okay? So some movie patrons have a narrower band, the IQs aren't that different. Okay? A simple random sample of 40, that's good, isn't it? You know one of our criteria for our tests was what? Greater than 30, so that's good. Results in IQ score with a standard deviation of 14.8. Is there sufficient evidence to support this claim? Do you think that through this test, if this standard is 14.8, can you say that all movie patrons have a narrower band of IQs than the general population based on the sample? Probably not, I would say. I mean, 14 planets are almost different than 15, isn't it? And didn't really tell us a whole lot about, I don't know, what confidence percent that was and things like that. So it's not really that much to make that claim. It's kind of a what if. Here's your first thing I want you to write. H sub 0. Those two letters, H sub 0, means the null hypothesis. See all those letters you don't have to write something when you write H sub 0? Isn't that great? That's why math's such a great topic. Great class. Okay. Let me go back. First time I taught this, we kind of blew over this part. So we're going to go back and underline the red for the next people that came through. It's equal to some claimed value. So you'll have H sub 0 equals. Okay? And then you'll write down your number. That's the null hypothesis. Got that right? Equals some claim. We test the null hypothesis directly. Now you either reject it or you fail to reject. Those are your first keywords. So when you're done, you actually use the words. We reject the null hypothesis based on blah, blah, blah. Or we fail to reject the null hypothesis. You know what fail to reject means? No, you don't accept it. Why? What do you do when you don't sure what to do? What words are told you to remember to this point in time in your life?
We cannot,
Yeah, we don't have enough information to accept it, but we do have enough information to fail to reject it. Okay? So don't think because you reject it or fail to reject it that you're accepting it. You're not. And that's kind of an important deal. Okay? So, you'll see why later on with more practice. H sub 1, possibly know about these. That's the alternative hypothesis. That's what your second statement would be. The alternative hypothesis. Yeah, that's it, that's awesome. What math symbol is used in the null hypothesis? What math symbol is used in the null? H sub 0, what else is there? H sub 0 equals. What symbol is going to be used in the alternative hypothesis? H sub 1 does not equal. H sub 1 is less than. H sub 1 is greater than. Here comes a key point. If I remember correctly, this means a left tail test. That's less than. This means not equal to. I think it means a two-tailed test. We'll double check. And this means, what do you think it means? A right tail test. I think that's how it works. I could be wrong. Anyway, so you see the need for pictures to go along with our hypothesis test. Okay, so we're going to be drawing these things out. So, for the alternative, you have to have H sub 1 and one of these symbols. For the null, you have to have H sub 0 and equals. Right? The wording of the test will tell you which one to pick. Alright? So, and that link is the third lecture for YouTube to the Khan Academy. I think we went there one day, but it wasn't that impressive. Alright. To conduct a study, you want to use hypothesis to support your claim. The claim must be worded so it becomes the alternative hypothesis. Okay, we'll practice that. I realize that looks kind of wordy right now. We'll do some practice ones here in a minute. This is in your textbook. It's figure 8.2. It's just a flow chart of what we talked about. Basically, the steps you're going to do at the beginning of the hypothesis test. Okay? You're going to find the alternative. You're going to express it in symbolic form with the alternative, and then you're going to get your test started. Okay? So, consider the claim. Everybody makes claims. TD, media, all four claims. I make claims. I go to board meeting about our math department. Okay, so there's a claim. The mean rate, what's the mean use for mean? You ready, Daddy? Yep. That means the population mean is at most 195 pounds. What does that mean? Give me an example of a carry-on baggage at most 195. Give me a number where it works. Give me an example of a carry-on baggage that is at most 195 pounds. This is including the passenger. Okay? I just want to see if you can understand what's being asked. Here's 195. What would this claim be? Yeah? It could be anything less than 195. Could be 195 itself. Okay, so we're saying that the mean is going to be less than or equal to 195 pounds. That includes airline passengers. Okay? Alright. They're saying, using the Federal Aviation Administration, procedures identify the null and the alternative hypothesis. Okay? So here's our claim. Every person has valid 195. So, step one. We just did that. In symbolic form, the claim is the mean is less than or equal to 195. Okay? We're going to use our symbol. We're going to start with the words meant, and we put it in math terms. Not too difficult. Step two. If the mean is less than 195 is false, then this 195 must be true. Does that make sense? How it's worded. So, if this is a false statement, then this part has to be true. Remember, a statement is true or false. Can't be both. Alright, let's try the third one. Step 3. Write down the alternative and the null hypothesis. So this statement right here, U greater than 195 does not contain the equality, so that the alternative hypothesis be this. U is greater than 195. So the null hypothesis is equal to the target number. So the null hypothesis, the mean equals 195 pounds. The alternative hypothesis is the mean is greater than 195. Okay? The alternative is that the mean is not too bad for the null hypothesis. Oh, do you know why it's called null? Because some people use the symbol as not or null, an empty set. If you took the stats, or if you took the math course, I talked about that at one time. And here's what some people have a problem with. The original claim is that most 195 is neither the null or the alternative hypothesis. Okay? There's nothing you can memorize through this. You actually have to think your way through all these questions. That, again, itself is one of the things that will be true. So here we go. Examine a given statement, and I want you to actually write this down as practice. Examine the given statement and express the null hypothesis and the alternative hypothesis in symbolic form. Be sure to use correct symbol. The proportion of people aged 18 to 25 who currently use illicit drugs is equal to 0.20 or 20%. Okay. That's the claim. First of all, which symbol is it? Write that down. I think the null is pretty easy in this case, don't you? I guess the P, right, for the proportion. So the original claim is P equals 0.20. Okay? Yeah. No, we're saying that this is the hypothesis. The null hypothesis is this statement right here. Okay? Then, H1. Do you think about anything that says less than or greater than? So what symbol does it have to be with hypothesis of relation? Not equal to. Okay? So the population proportion is not equal to 0.20. Okay? Questions? Yeah. Why is the numbers hypothesis because the statement's either true or false. There's no third side to the claim, so to speak. So, if this is the claim that the proportion uses 20%, the flip side of the argument is it's not going to be 20%. Both sides. Yes. No, we're not disagreeing or agreeing. We're just setting up a test. And to set a test, you have to have two outcomes. Okay. One, to reject the claim, or to fail to reject the claim. But we're not supporting anything. Okay. So we're setting up a test so we can have an outcome, one way or the other. It's hard. I mean, that's why this chapter takes so long, just the wording of it and the thinking of it. Okay? Here we go. The majority of college students have credit cards. That's a claim. If you understand, if you go through this, you might understand why I make the comments I do sometimes when you say things. You know how you look at me when I say things? You can say, every senior is going on the field trip. I go, every senior? So they made that statement. Okay? But not every single word. So, what do you think the null hypothesis would be? First of all, what do you think the majority is? Over half. Do you think the majority is equal to half? Do you win a vote if you get exactly half the votes? No. In one of those heated presidential elections, somebody got 50.4% of votes, and I got the majority of people's vote, and the people who spoke when I'm now president. 50.4%, just enough to say you got the majority. Random. Maybe some of you got 85%, he said. It's the majority. So, let's see. Here we go. So there's the original claim that P is greater than 0.5, okay? So what do you think the null hypothesis will be? Yeah. What symbol has to be used in the null hypothesis? Yeah, 4 symbols you can choose from. Equal? Yeah, that's what I would say. P equals 0.5. The null hypothesis always has to be equal to your claim. Regardless of what the claim says or how it's worded, you're setting up a formal test. To set up a formal test means it has to be done the same way every time, So you have validity. Okay, I don't know how many do chemistry experiments or stuff like that, but it has to be set up the same every time, so it's valid. I think that's a difficult one. What would be the alternative hypothesis? Hopefully everybody knows it's P. And you got three choices in the symbol. And you also have to get which one it is. What do you think? Well, it's not going to be not equal to because it is the majority. So in the majority, you're claiming that, if I put a line right here, that this many college students have one. Okay? Well, and it also said, do you want to support this or do you want to try to reject the claim? That's also another thing that we talked about. I don't think they told us whether they want to support it or reject it right now. So, 0.5. You're right. I would go with, I think I would go with less than, but not equal to. The mean weight of plastic discarded by household in 1 week is less than 1 kilogram. What's the symbol for mean weight? Clayton, you know the symbol? It's U. Okay. So, what's going to be the alternative or the null hypothesis? Okay. The mean equals 1 kilogram. And judging by the last time, I said it's going to be not equal, wouldn't you? What's going on? Well, I don't know. We'll have to figure it out.
So no matter what, the null hypothesis has to be,
Exactly. No matter what, the null hypothesis has to be equal. And we're starting to figure out why the alternative hypothesis is flipping around back and forth. I have no idea. The majority of college students have credit cards. So that could be 60%, that could be 70%, 80%. Kind of vague, isn't it? The other one has the actual word less than in it. I would say that's probably a good thing. If the original claim is very specific, you can become very specific with the alternative hypothesis. If it's vague, what symbol you're going to choose? Not equal to. That covers every number except the claim number. The less than only covers some numbers. The greater than only covers some numbers. But the less than covers everything but the claim. The not equal to is a very powerful alternative hypothesis. Okay, so the wording is very important. Okay, so right now I'm going to shut this down. There's another link you want to go to on hypothesis is fine. I want you to read the book out and work to the end of the period. I'm not giving you assignments for the next 4 days, so make sure you get that from Ross or something, okay? Yeah. Okay, I'll take a look at that.